Welcome back. Before we get started on the next lesson, I wanted to take a moment to talk to you a little bit about the framework in which we build data acquisition systems for our environmental or weather measurements. So on the screen right now you see this simple block diagram which I think kind of shows the key five components of any data acquisition and control system. First off, of course, you need the sensors that you see up here at the top. These are what are interacting with the environment, actually measuring the temperature, humidity, pressure, radiation, dust, whatever you're interested in. Now, our microcontroller boards are normally in this class or set of lessons is the Arduino Uno, Metro, but it could be, wide as I showed in the lesson 0, lots of different microcontroller boards or even just the microprocessor itself that can act as sort of the brains of the system, coordinating all the activity between the sensors and the other components. You also, of course, always need power, and if you're outdoors, a lot of the time that's battery power and maybe assisted by a solar panel. That's the most common approach. If you're someplace indoors, you have line power and you can maybe provide a line source AC power to your system. So you always need sensors, some type of microcontroller or microprocessor, and a power system and an enclosure. You don't want to overlook these two. I've got a lot of experience, and sometimes these things are so interesting and you forget about how important power and enclosure are, and that will derail your attempts to get good environmental measurements. Of course, you normally want to log the data or store it, and we do that on an SD card or EEPROM. In these lessons, we're mainly going to use the SD card. It's a little easier to do and easy to get our data over to the computer for further analysis, but an essential part of any data acquisition system. Finally, the data that we do store on the card, we usually want it time stamped. That is, because environmental variables change with time, we need a real-time clock that can keep track of time and date even when the power to the system is turned off, so that when the system is reactivated, it knows the time and date and can timestamp any information that's going over to the SD card. So you almost always need these 5 pieces or components as a framework for any data acquisition and control system in environmental science. Now, sometimes you want to add extra features to your system depending on your project goals. So I've added 4 additional blocks to our framework, and let's go through these real quick. Sometimes you want some type of user interface, and this can be as simple as a couple of LEDs that flash every time a measurement is taken or stay on when there's some kind of an alarm condition. Could be a couple of buttons or switches that the user can press to put the system in different mode or start and stop the system. Can be very simple and inexpensive. Often folks want to put like a display on their system so that they can get a real-time measurement or a real-time view of what the sensors are recording. So we'll study LCDs and OLEDs and how those can be connected to your data acquisition and control system. Remember, those add cost and complexity and power. A lot of the time, if you're in a really remote location, sometimes it's not the smartest thing to put a display on your Datalogger system. Often we want to build something that can control an external device. Let's say we want our system to measure soil moisture in our garden and then turn on an irrigation system when the soil moisture is dropped below a certain value. So we need to control external devices, valves, motors, pumps, fans, all kinds of things. And that's one of the most powerful uses of the Arduino and do-it-yourself electronics, is that you can build your own systems to do these types of interesting management activities, to control water, control sampling, do all kinds of interesting things. So sometimes that requires some extra circuitry, and we'll study that as well. Depending on your goals, you may want communications with your system that can be posted on the web or downloaded from a remote location. So we need to add communications like Wi-Fi, radio, or cellular. And we'll cover that as well. With all the interest right now in the Internet of Things, that is, connecting these systems to the Internet and having them downloaded to services where you can see the data real time or share that with others across the globe. I think this is a really growing and exciting area of environmental measurement, especially in the terms of citizen science. So we'll study how to connect your system to the internet and move your data onto the cloud for analysis. Finally, there's all kinds of other things we might want to add to our microcontroller system. I think one of the most common is GPS. If your system is mobile, it's really great to have a GPS on there. Log position also gives you a very accurate measurement of time. So if you have a GPS, sometimes you don't need the real-time clock. So this diagram gives you a nice framework to think about data acquisition and control systems and how it relates to your project goals.